Hello again everybody, and welcome to the fifth and final video in this series on performing car counting in OpenCV. And let's go ahead and dive right into it. Actually, before we dive into it today, I should mention that the prerequisite for this video today would be the first four videos in this series, as well as the OpenCV installation and configuration video. Please view those if you have not already, and I'll link those all in the description below. So let's go ahead and get started today. So GitHub, micro, microcontrollers, and more, and take out the spaces. And then let's go ahead and fire up Visual Studio, and then we'll go to here, and then repositories, and then let's see, car counting. Where are we here? OpenCV 3 car counting CPP. And this is going to be a pretty similar directory structure to the previous video. We have our blob class, and this is really the only file that's different here is cars driving under bridge.mp4, which is some video of cars driving under a bridge that I recorded by a bridge near to where I live. Of course, we're going to use that instead of the video of people walking around from the previous videos in the series, and then we have main and readme as before. So I'll go ahead and copy and paste out of each of these. So if you simply go to raw, you can copy and paste out of here pretty easily. So let's go to Visual Studio, and then I'll swing this over to the other screen and we can get started here. So file, new project, and then we may as well name the project the same as the repository. So car counting OpenCV 3 car counting CPP. Make sure you have Visual C++ and empty project chosen. Choose your preferred location, uncheck those, and then choose OK. And then we're going to add three files on the left here. We're going to add main and blob.h, so and blob.cpp. So if we go new item, and then that's going to be main.cpp, and then we're going to add a new item, and this will be blob.cpp, and then we're going to add new item, and then we're going to add blob.h. And we're going to go ahead and copy and paste in each of those. So this here is main, add that first, and then we're going to add blob.cpp and copy that in from the other screen there, and then we're going to add in blob.h, and there we go, and raw, and then we're going to add our references next, because of course we're going to get red underlines here. We haven't yet told Visual Studio where to find OpenCV, and again, if you're unclear on these steps, please see the installation and configuration tutorial. I'm copying and pasting out of a cheat sheet from that video, and I'll link that in the description below. So there's include, and then we're going to get our library directory next, and that's going to go right here, edit, and then we're going to add in our linker, input, and additional dependencies, and edit. We're going to add our library in there, and apply and OK. And let's go ahead and do a release. Oh, whoops, I forgot to change this to x64. Sorry, got to do those steps again. That's a must with OpenCV 3 or later, but that just take a second. So Visual C++, include directories, edit, and paste that in, and then we're going to paste in the library directory again, and there we go, edit, and then do that, and then we're going to add in our debug library as well, OpenCV world, and then edit, and then paste that in. And so this runs a little faster at the end. We're also going to do the release version, and it's pretty much the same steps. So we're going to go to let's see here, Visual C++ directories, include, edit, and then include path is the same for debug or release with the precompiled binaries at least, and then library directories. If you're compiling from source, there may be some slight differences there. That's something to consider. And then the library directory is the same as for the debug and release versions, and then for the library itself, all we have to do is take out the D to change from the debug to the release version. Whoops, don't want to add those in there. Okay, there we go. Apply OK. And let's go back to the debug version for the moment. So the only remaining thing is you want to download this Cars Driving Under Bridge video from the GitHub repository. I just pre-downloaded it here to save some time, so we're going to copy that into the project directory, and there we go, it's in the project directory. So now we can go ahead and run the program, and once we've verified it's working okay, then we'll go ahead and take a look at the code. So this is going to be pretty similar to the previous programs in this series here. So here's our threshold image, and then here's our contours image. and then here's our convex hulls image, and then we can eliminate all this noise here with the conditional statements we took a look at in the last program, picking a certain minimum size and aspect ratio and everything pertaining to the blobs. So there's the blobs, current frame blobs. Here's the blobs that are matched to our vector of blobs where we keep track of each blob from one frame to the next. And then here's the actual program result, and I'll go ahead and run this. Actually, let's choose the local Windows debugger so it runs a little slower so you can see the cars being counted. And we've got 100% success rate with this particular video with this program, and the numbers on the cars here as you see them passing, of course, that's not a count, that's just simply the ID or the position in the vector of the cars. The count is at the top right here, so you can see 12, 13, 14, 15, 16, 17, 18. You can see we're pretty successfully counting the cars. 19, 20, so then I'll stop this here and then I'll run it in release mode so it goes a lot faster, so you can see them being counted. I believe there's 52 is the total count by the end, and it only takes maybe half a minute to a minute to run through it. So 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15. Again, we're looking at the counter in the top right here, and so that we can see this is pretty successful as far as tracking cars. I've of course made this specific to the cars moving upward, but if the cars were moving sideways or downward, it wouldn't be too difficult to change things programmatically. And depending on how far away the camera is from the cars, you may need to change the morphological operations, the openings and closings a little bit. Maybe some necessary changes based on lighting, based on a certain situation, but this is a pretty robust program that'll work generally pretty well for most cases. So let's take a quick look at the code. So here we have our global variables, they're really just colors, and then we have our function prototypes. And here we're simply loading the video and doing some basic error checking. We covered that in part 1. And then here we're doing basically some pretty straightforward, well actually here we introduce a few additional things here for car counting, the horizontal line position, and then the crossing line, which we define as 2 points. And then when we jump into our while loop, we are simply doing basically image subtraction, the same as in the second video in this series. And then we work through getting our convex hulls and then our current frame blobs. And then we call, if we're in our first frame, we add each current frame blob to blobs. If we're past the first frame, then we call this function match current frame blobs to existing blobs. And we did take a look at this in the previous video, so I won't go over it in too much detail here, but basically the idea is this. If we have, I made the slide here, so if this is a blob here, these 3 black circles, and then the dashed one is our predicted next position, and then same thing here and same thing here, and then say that the blue circles here are the actual current frame result. Well, what we're going to do is, starting with this blue blob here, we're going to compute the distance to this prediction, to this prediction, and to this prediction, and then we're going to see which of those is the least. Obviously this is the distance to the least distance to a prediction, and then if that distance is less than a certain amount, then we're going to say that this is a match, so then we're going to add this blob to this set of previous points here. And so let's take a look at doing that here. So by default we sort of iterate through existing blobs, and we suppose that each of those is by default does not yet have a match, and then we predict the next position of the existing blobs. Then we loop through our outer for loop here for the current frame blobs, and then we have an inner for loop for each of the existing blobs, and then we get that distance between the current frame blob and the predicted next position of the existing ones. And if that distance is less than our threshold amount, which is going to be the current frame blob's diagonal size times a half, then we're going to add that current frame blob to our existing blobs. If not, then we're going to say that that must be a new blob that just entered the frame. So we're going to add new blob. And then at the end here, what we simply do is we go through existing blobs again, and we check if the current frame blob a match found or new blob is still false, and if it is, we increment the number of frames that that blob has gone without a match, and if that gets to 5 or more, then we say that we're not tracking that blob anymore. So in other words, that's one that must have worked its way off the edge of the screen. And after that, it's pretty similar to the previous program. We have add blob to existing blobs, add new blob, distance between points, draw and show contours, and then we have this additional function here to check if a blob or blobs have crossed the line. And again, that's simply a matter of checking if in the previous frame the blob was below the line, and then if in the next frame it's above the line. And for example, if you wanted to count cars that were moving downward on the screen instead of upward, you could simply reverse the logic here. It would be pretty straightforward and not very hard to adapt. And then if at least one blob crossed the line, we're going to return that. Because if a blob just crossed, we're going to draw the crossing line as green. That's why you may have noticed the line blinked green when a car was crossing rather. And then of course we also update car count, which is passed by reference here, and then that was what was showing in the top right of the screen. And then we simply draw the blob info on the image. That's the red bounding rectangle you saw, and the blob ID that was in green. And then we draw the car count on the image, and that was the car count at the top right. So that's worked out pretty well for us, and hopefully this has been a beneficial tutorial for everybody out there as far as how to perform object tracking. And as far as any feedback in the comments below, if you found the way I sort of started with a real simple example in this 5-part video series and built up to this more substantial program, if you found that beneficial, please let me know. Or if you'd maybe in the future rather I just cut to the chase and show the final program, let me know about that. And in any case, please rate, comment, and subscribe, and I'll see everybody in the next one.